Hi guys, welcome back to the channel. Once again, my name is Jag, and today's class we're going to cover Chemistry 11. Again, this is a very simple topic. It's basically converting moles to the number of particles. Alright, with that, let's get started. Oh, so you're probably wondering what is a mole, Jag. So let me explain to you what that is. A mole is basically, I like to think of it as the amount of substance. Okay, it is a scientific unit, and I'm using that to measure really small quantities. So just like in this case, it could be the number of atoms, the number of molecules, or the number of particles, and they all mean almost the same thing. Okay, in the example that we're going to look at, you'll see that just the calculations for the number of atoms and the number of molecules is just going to be slightly different. Okay, so with that, let's get started. Alright, so I'm going to put the number of moles, okay, on one side over here, okay, and on the other side I'm going to just put the number of particles. So one more time, the number of particles can actually include atoms, molecules. Even if you see something like formula units, that does actually mean the same thing, okay? And what I need to remember here is there's a very important constant. This is called Avogadro's constant, okay? I have to make sure I do memorize this number. Most teachers will not give you this number on a test or a quiz. Alright, so we are going to memorize it. When I'm changing the number of moles here, okay, to the number of particles, I have to make sure I multiply by Avogadro's constant. So I'm going to write down the constant in brackets here. It's 6.02 times 10 to the power of 23, okay, like that. Okay, and in the reverse form here, when I change from the number of particles back to the number of moles, I'm going to divide by Avogadro's constant. So I'm going to write his constant one more time over here. Okay, and this is really what you need to remember. It's kind of like a chart, okay? Make sure you don't reverse both of these, okay? So from the moles to the particles, you're multiplying by Avogadro's constant. When I'm going from the number of particles back to the number of moles, I have to divide by Avogadro's constant, okay? So depending on what textbook you're using, most textbooks do have this chart, and I usually make sure I am memorizing this chart because there will be variations of these questions. So we should be able to find the answer for all of these questions, all right? Okay, so with that, let's get started. So what we're going to go through here is an example. Okay, let's take the example from the textbook. Okay, and the reason for that is there are two parts to this question. And in one of the parts, you do have to calculate the number of atoms. Okay, and I want to just show you what the difference is in this case. Okay, so what we're going to do is I'm going to read out the question, okay, from the textbook. And I'm going to write down what is given here as well, okay? A sample contains 1.25 moles of nitrogen dioxide, so like that. And again, remember the teacher does not have to give you the formula. The teacher might just say nitrogen dioxide. I have to make sure I remember that this is a molecular compound, and I have to use the prefix method, okay, when I'm actually writing. So I'm going to put here prefix method, okay, when I'm writing out the formula. Okay, so nitrogen dioxide, because there are two atoms of oxygen here, okay, and that is the prefix method. Okay, so part A says how many molecules are in the sample, okay? So let's put that. So I'm going to do number of molecules, okay, in the sample. And what you're going to do here is I'm already given the number of moles. So I have to take the number of moles. I'm going to multiply it by Avogadro's constant. Again, make sure you're showing all your work as you're writing it down. So I'm going to do 1.25 times. And I always put Avogadro's constant in brackets, okay? Just to make sure I'm getting the right answer. So 6.02 times 10 to the power of 23. And again, just like in math, just make sure you're putting the equal sign going down. Okay, and we are going to put this into our calculator here. If you want, you can put Avogadro's constant first, and then I'm going to put times 1.25, okay? We're gonna round this to 2 decimals, so 7.53, okay, times 10 to the power of 23 molecules. Okay, does everyone see how to do that? So it is a very simple calculation, okay? And make sure your answer at the end is like really big, okay? And there has to be an exponent that you're getting the answer with here, okay? And that's going to be the number of molecules, all right? So let's go to part B here. So I'm going to just take off the first part. Okay, and part B is asking about the number of atoms, okay? So part B says, I'm just going to read it out loud so everyone can hear it. So how many atoms are in the sample, okay? So I'm going to put here number of atoms. Okay, and different teachers will use like different notations, okay, for the formula. Okay, I have to remember that actually. So a lot of teachers will use NA, so the A should be capital here. This actually includes Avogadro's constant. Okay, that's NA. And usually N is used to indicate the number of particles. Okay, and when you're indicating the number of moles, you have to use a small n. Okay, so it has to be a lowercase n. So I'm going to put number of moles. Okay, so these are basically the variables that we should be using. Okay, usually it is like a constant. Okay, and A is just meaning Avogadro's constant. All right. And that's just because we are going to go through later on in the next video. I'm going to bring out the content for calculating the number of moles. And the number of moles is always indicated, okay, with the lowercase n. Alright, so let's get back to our example here. Alright, so we were doing the number of atoms, okay. I do have to use my answer from part A, so I'm just going to write that one more time. Okay, we'll put 5.2 here, okay? This is how they were rounding off their number for part A, okay? Again, if your answer is off by just like 1 decimal place, it's not going to make a big difference. I haven't seen teachers take off marks for that, okay? So what we're going to do now is I'm going to take the number of molecules, okay, from part A, and I'm going to multiply it by the number of atoms here, okay? And in this case, if I'm counting the number of atoms, there are 2 atoms of oxygen, okay? I'm adding that to 1 atom of nitrogen. I have 3 atoms altogether, okay, within this molecule here. Okay, so I'm going to take Avogadro's constant. So let's put 5.3, okay, because that's what we were using here. And I'm just going to multiply that by 3. So we're getting 2.25 times 10 to the power of 24 atoms. Alright, and just like that, you can see the calculations are actually very simple. Okay, and again, if there are 2 parts, after each part, I would make sure that I am putting a concluding sentence. So it should be a therefore sentence, okay, at the end. So therefore, the number of atoms of this molecule of nitrogen dioxide is 2.25 times 10 to the power of 24 atoms. Alright? So this is how we are basically converting the moles to the number of particles. And again, just like we did in our chart, if you're going in the other direction, I'm going to take the number of particles that I have and I'm going to divide it by Avogadro's constant, and that's going to give me the number of moles. So I hope you found this video really helpful, and if you did, please make sure you're clicking on the like button and also subscribe to the channel. And I'm going to keep on bringing out some new content associated with Chemistry 11. And if there are other subjects that you are taking, perhaps maybe this fall, and you want to see some content on that, please just leave a comment in the section below. So thank you once again for watching this video, and I will see everyone next time. Bye!